What is up? What's up, my droids? We're back. We're here. We're going to do a game development stream. You know you wanted it. Let's just check that audio one last time. Everything good there? Let's see. Yeah, good. All right. Welcome back. So we're going to do something related to our game project. If you guys don't remember, we started in Unreal Engine. This is a game designed by a friend of mine. We used to have a wannabe game studio called New Seattle Games. He was from New York. I was from Seattle. We both were in California. We decided to call it New Seattle. Long story there. But we're going to start here by downloading a new engine. It's actually been around a while, but new for me, called Godet or Godet or Godet or Godet or no, it's Godet. I call it Godet. It is Godet. It's not the first search on Google. Godet game engine. I know you can't see what I'm typing. Found it. It's a free 2D and 3D game engine. What's unique about this one is that it's open source, meaning, should I get latest or LTS? Meaning you can go look at the code for the engine itself. You can change it. You can put a pull request in if you want to on GitHub. I'm assuming it's on GitHub. I should actually check that. All right, Godet engine, GodetEngine.net. What's the difference? They're both Intel Apple Silicon. C# support. Tempting. Let's .NET is terrible on Macs, unfortunately. I learned that recently. A comprehensive tutorial. We're gonna go with the Godot scripting or whatever it's called. It's like a very JavaScript looking scripting language, not full blown C#. So let's do that. I want to see how fast we can get off the ground with this new engine. Part of the reason why I just think I'm going to abandon Unreal Engine is that it just takes forever to do any one little thing, and I don't have a ton of time these days. I've got 5 side projects, a full-time job, and some other stuff in the pipeline. So as that downloads, or looks like it did, I'm gonna install it now. You can think of this as a tutorial for how to install a game engine. No, I'm just kidding. Downloaded it, double-clicked it, opening it. Again, I'm on Mac. A lot of developers use Mac. Been on it for years. Also have a PC. Never use it. You currently don't have any projects. Would you like to explore official example projects in the asset library? Sure. Let's look that up. Recently updated all. Engine.org. Oh, sorry. Tired. All right. Don't see it. Recently released. A to Z. All templates, projects. Looks like their asset store is not loading. I'm going to close this and reopen it. So it did not put it in the apps folder. Maybe when apps don't do that. Open it now. It has been moved. Oh, open. All right, trying one more time. Open asset library just to see. Maybe it'll work this time. No results compatible with Godot 4.2. I guess it's just 2 new guys. When did this come out? Take me somewhere? Did not. Might have to go to the LTS version. Edit on GitHub. The docs. All right, here we go. This is the engine itself. There's also a project for the demo. Let's read a little bit about it. Godot Engine is a feature-packed cross-platform game engine to create 2D and 3D games from a unified interface. It provides a comprehensive set of common tools so that users can focus on making games without having to reinvent the wheel. Games can be exported with one click to a number of platforms, including the major desktop platforms, Linux, Mac OS, Windows, mobile platforms, Android and iOS, as well as web-based platforms and consoles. Free open source, community driven. Godot is completely free and open source under the very permissive MIT license. No strings attached, no royalties, nothing. The user's games are theirs, down to the last line of engine code. Godot's development is fully independent and community driven, empowering users to help shape their engine to match their expectations. It is supported by Godot Foundation, not for profit. Before being open source in February 2014, Godot had been developed by Juan Linietsky and Ariel Manzur, both still maintaining their projects, for several years as an in-house engine used to publish several work-for-hire titles. Getting the engine, binary downloads, compiling from source, community, and contributing. Godot is not only an engine, but an ever-growing community of users and engine developers. The main community channels are listed on the homepage. The best way to get in touch with the core engine developers is to join the Godot contributors chat. To get started contributing to the project, see the contributing guide. The document also includes guidelines for reporting bugs, documentation, and demos. The official documentation is hosted on Read the Docs. It is maintained by the Godot community in its own GitHub repository. The class reference is also accessible from the Godot editor. Oops. We also maintain official demos in our GitHub repository, as well as a list of awesome Godot community resources. Scan those real quick. There are also a number of other learning resources provided by the community, such as text and video tutorials, demos, etc. Consult the community channels for more information. 940 code helpers. 36% translated. 494 to-dos. Man, I might actually commit to this if I get time, and it makes sense. 5,000 plus issues. Input, parse input event does not work on version 4.2.1. We should get the LTS. I'm not sure we should be on the latest. Input, parse input seems very important to be broken. Use 4.1.1 to see correct operation. Run the current scene. Press the button that appears. You will see a message displayed while the button is being pressed. Then use Godot 4.2.1. Run the current scene. Press the button that appears. Message indicating that the button has been pressed will not appear. Minimal reproduction project here. Example. What version did we just download? 4.2.1. It is mobile though. Oh, Windows 10. The mobile version doesn't work? Okay, let's see how far we can get. If we get into some real weird stuff, we might just downgrade. 2,000 open PRs? What the heck is happening? Fix Godot edits text white box showing during game load. Remove unnecessary this expressions. Add get button color. C# fix issues with string name reference and C# instance bridge.get. Add methods to get argument count. All right, a lot of active development. Cool. Up to date. This page is up to date for Godot 4.2. If you still find out that information, please open an issue. Godot Docs 4.2 branch. Godot's documentation is available in various languages and versions. Expand the Read the Docs panel at the bottom of the sidebar to see the list. Welcome to the official documentation of Godot Engine, the free and open source community-driven 2D and 3D game engine. If you're new to the documentation, we recommend that you read the introduction page to get an overview of what this documentation has to offer. The table of contents in the sidebar should let you easily access the documentation of your topic of interest. You can also use the search function in the top left corner. Get involved. Godot Engine is an open source project developed by a community of volunteers. The documentation team can always use your feedback and help it improve the tutorial closet. If you don't understand something or get off, you're looking for the docs, but help us blah 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 blah. Offline documentation. Cool. it directed me to this page. Introduction. Func_ready. Print hello world. Welcome to the official documentation of Godot Engine, the free and open source community-driven 2D and 3D game engine. Behind this mouthful, you will find a powerful yet user-friendly tool that you can use to develop any kind of game for any platform and with no usage restrictions whatsoever. This page gives a broad overview of the engine and of this documentation so that you know where to start if you're a beginner or where to look if you need information on a specific feature. Before you start, the tutorials and resources page lists video tutorials contributed by the community. If you prefer video to text, consider checking them out. Otherwise, getting started is a pretty good starting point. I thought this was the starting point. In case you have trouble with one of the tutorials or your project, you can find help on the various community channels, especially the Godot Discord, community, and forum. The game engine is a complex tool and difficult to present in a few words. Here's a quick synopsis, which you are free to reuse if you need a quick write-up about Godot Engine. Godot Engine is a feature-packed cross-platform game engine to create 2D and 3D from a unified interface that provides a comprehensive set of tools. Yeah, we already talked about this. Godot is completely free. We talked about that. Organization and the documentation is organized into several sections about Godot's introduction, as well as information about the engine, its history, its licensing, authors, etc. It also contains the frequently asked questions. Getting started contains all necessary information on using the engine to make games. It starts with a step-by-step tutorial, which should be entry point for all new users. This is the best place to start if you're new. The manual can be read or referenced as needed in any order. It contains feature-specific tutorials and documentation. Contributing gives information related to contributing. Community is dedicated to the life of Godot's community. It points to various community channels. Finally, the class reference documents the full Godot API, also available directly within the engine script editor. You can find information on all classes, functions, signals, and so on here. In addition to this documentation, you may also want to take a look at the various Godot demo projects. About this documentation, all documentation content is licensed under the permissive Creative Commons attribution. Cool. Did it say 2014? It did. Introduction. This series will introduce you to Godot, and spelling Godot wrong before. That's probably why I didn't find it when I searched. In the following pages, you will get answers to questions such as, is Godot for me? Or what can I do with Godot? We will then introduce the engine's most essential concepts, run you through the editor's interface, and give you tips to make the most of your time learning. Introduction to Godot. This article is here to help you figure out whether Godot might be a good fit for you. We will introduce some broad features of the engine to give you a feel for what you can achieve with it and answer questions such as, what do I need to know to get started? This is by no means an exhaustive overview. We will introduce many more features in this Getting Started series. What is Godot? Godot is a general purpose 2D, 3D, supports sort of projects. You can use it to create games or applications you can then release on desktop or mobile as well as on the web. You can also create console games with it, although you either need strong programming skills or a developer to port the game for you. The Godot team can't provide an open source console export due to the licensing terms imposed by console manufacturers. Regardless of the engine you use, though, releasing games on consoles is always a lot of work. You can read more on that here. What can the engine do? Godot was initially developed in-house by an Argentinian game studio. Its development started in 2001, and the engine was rewritten and improved tremendously since its open source release in 2014. Some examples of games created with Godot include X Zodiac and Helms of Fury. As for applications, the open source pixel art drawing program Pixelrama is powered by Godot, and so is the voxel RPG creator RPG in a Box. You can find many more examples of this official showcase videos. How does it work and look? Godot comes with a fully fledged game editor with integrated tools to answer the most common needs. It includes a code editor, an animation editor, a tile map editor, a shader editor, a debugger, a profiler, and more. The team strives to offer a feature-rich game editor with a consistent user experience. While there's always room for improvement, the user interface keeps getting refined. Of course, if you prefer, you can work with external programs. We officially support importing 3D scenes designed in Blender and maintain plugins to code in VS Code and Emacs, the GD script and for GDScript and C#. You also support Visual Studio for C# on Windows. Programming language. Let's talk about the available programming languages. You can code your games using GDScript, a Godot-specific and tightly integrated language with a lightweight syntax, or C#, which is popular in the games industry. These are the two main scripting languages we support. With GD extension technology, you can also write gameplay or high-performance algorithms in C or C++ without recompiling the engine. You can use this technology to integrate third-party libraries and other software development kits in the engine. Of course, you can also directly add modules and features to the engine, as it's completely free and open source. What do I need to now use Godot? Godot is a feature-packed game engine with its thousands of features. There is a lot to learn. To make the most of it, you need good programming foundations. While we try to make the engine accessible, you will benefit a lot from knowing how to think like a programmer first. Godot relies on the object-oriented programming paradigm. Being comfortable with concepts such as classes and objects will help you code efficiently in it. If you are entirely new to programming, we recommend following the CS50 Open Courseware from Harvard University. It's a great free course that will teach you everything you need to know to be off to a good start. It will save you countless hours and hurdles learning any game engine afterward. Note, in CS50 you will learn multiple programming languages. Don't be afraid of that. Programming languages have many similarities. The skills you learn with one language transfer well to others. We will provide you with more Godot-specific learning resources and learning new features. In the next part, you will get an overview of the engine's essential concepts. Overview of Godot's key concepts. Every game engine revolves around abstractions you use to build your applications. In Godot, a game is a tree of nodes that you group together into scenes. You can then wire these nodes so they can communicate using signals. These are the four concepts you will learn here. We're going to look at them briefly to give you a sense of how the engine works. In the Getting Started series, you will get to use them in practice. Scenes. In Godot, you break down your game in reusable scenes. A scene can be a character, a weapon, a menu in the user interface, a single house, an entire level, or anything you can think of. Godot's scenes are flexible. They fill the role of both prefabs and scenes in some other game engines. Okay, so a character can be a scene. So, prefab. Interesting. Basically a template. You create a template that can be instantiated. Interesting. Cool. You can also nest scenes. For example, you can put your character in a level and drag and drop a scene as a child of it. Game level player hook. Nodes. A scene is composed of one or more nodes. Nodes are your game's smallest building blocks that you arrange into trees. Here's an example of a character node. It's got a camera 2D, a sprite 2D, and a collision shape 2D. It is made of a character body 2D node named player, a camera 2D, a sprite 2D, and collision shape 2D. The node names end with 2D because this is a 2D scene. Their 3D counterparts have names that end with 3D. Be aware that spatial nodes are now called Node 3D, starting with Godot 4. Notice how nodes and scenes look the same in the editor. When you save a tree of nodes as a scene, it then shows as a single node with its internal structure hidden in the editor. Godot provides an extension library of base node types you can combine and extend to build more powerful ones. 2D, 3D, or user interface. You will do most things with these nodes. Windows, subviewport, node 2D, collision object 2D, animated sprite 2D, audio listener 2D, audio stream player 2D, back buffer copy. The scene tree. All your game scenes come together in the scene tree, literally a tree of scenes. And as the scenes are trees of nodes, the scene tree also is a tree of nodes. But it's easier to think of your game in terms of scenes as they can represent characters, weapons, doors, or your user interface. Level 1 has a background layer with a texture rec, interface layer, user interface, tile map, character body 2D, portal 2D, coins, enemies. Nodes emit signals when some event occurs. This feature allows you to make nodes communicate without hardwiring them in code. It gives you a lot of flexibility in how you structure your scenes. A signal for area 2D, area entered, area exited, area shape entered, area shape exited, body entered, on area 2D, body entered, body exited, body shape entered, body shape exited. Signals are Godot's version of the observer pattern. You can read more about it here. For example, buttons emit a signal when pressed. You can connect to the signal to run code in reaction to this event, like starting the game or opening a menu. Other built-in signals can tell you when two objects collided, when a character or a monster entered a given area, and much more. You can also define new signals tailored to your game. Summary: nodes, scene, the scene tree, and signals are four core concepts in Godot that you will manipulate all the time. Nodes are your game's smallest building blocks. You combine them to create scenes that you then combine and nest into the scene tree. You can then use signals to make nodes react to events in other nodes or different scene tree branches. After the short breakdown, you probably have many questions. Bear with us as you will get many answers throughout the Getting Started series. First, look at Godot's editor. This page gives you a brief overview of Godot's interface. We're going to look at the different main screens, and docks to help you situate yourself. For a comprehensive breakdown of the editor's interface and how to use it, see the editor manual. Project Manager. When you launch Godot, the first window you see is the Project Manager. In the default tab, Local Projects, you can manage existing projects, import and create new ones, and more. At the top of the window, there's another tab named Asset Library Projects. You can search the demo project in the open source asset library, which includes many projects developed by the community. To learn the project manager's ins and outs, read the Using the Project Manager. You can also change the editor's language using the drop-down menu to the right of the engine's version in the Windows top right corner. By default, it is in English. First, look at Godot's editor. When you open a new or an existing project, the editor's interface appears. Let's look at this main areas. By default, it features menus, main screens, and playtest buttons along the Window's top edge. In the center of the viewport, with its toolbar at the top, where you'll find tools and move, scale, or lock scenes nodes. On either side of the viewport sit the docks, and at the bottom of the window lies the bottom panel. The toolbar changes based on the context and selected node. Here's the 2D toolbar. Below is the 3D one. Similar, yeah, different I guess here. Same, different. 3D has a couple extra things there. Let's look at the docks. The file system dock lets your project files, including scripts, images, and audio file samples and more. We'll list them. I totally misread that. File system. Cool. The scene dock lists the active scenes nodes. Scene. The inspector allows you to edit the properties of a selected node. Inspector. The bottom panel situated below the viewport is the host for the debug console, the animation editor, the audio mixer, and more. They can take precious space, that's why they're folded by default. Output debugger, audio animation, shader editor. When you click on one, it expands vertically. Below you can see the animation editor opened. The four main screens. There are four main screen buttons centered at the top of the editor: 2D, 3D script, and asset lib. You'll use the 2D screen for all types of games. In addition to 2D games, the 2D screen is where you'll build your interfaces. In the 3D screen, you can work with meshes, lights, and design levels for 3D games. Notice the perspective button under the toolbar. Clicking on it opens a list of options related to 3D view. Read Introduction to 3D for more detail about the 3D main screen. The script screen is a complete code editor with a debugger, rich auto-completion, and built-in code reference. Script. Finally, the asset lib is a library of free and open source add-ons, scripts, and assets to use in your projects. Nice syntax Godot 4. Instance doc. Sprite sheet generator. Script name on top. Rain lizard. You can learn more about the asset library in About the Asset Library. Integrated class reference. Godot comes with a built-in class reference. You can search for information about a class, method, property, constant, or signal by any one of the following methods. Pressing F1 or Alt space on Mac OS, or FN plus F1 for laptops with an FN key, anywhere in the editor. Alt space. It's funny. There is no Alt on a Mac. This needs to be updated. I found a bug. Yeah, this should be either command space or option space, probably. Clicking the search help button in the top right of the script main screen. Clicking on the help menu and search help. Click while pressing the control key on the class name, function name, or built-in variables in the script editor. When you do any of these, a window pops up. Type to search for any item. You can also use it to browse available objects and methods. Makes sense. Double click on an item to open the corresponding page in the script main screen. Animated Sprite 2D. Sprite node that contains multiple textures as frames to play for animation. Description. Animated Sprite 2D is similar to the Sprite 2D node, except it carries multiple textures as an animation frames. Animations are created using a sprite frames resource, which allows you to import image files or folder containing said files. To provide the animation frame for the sprite frames resource can be configured in the editor via the sprite frames bottom panel. We're going to be using that pretty soon, I'm sure. All right. Learning new features. Godot is a feature-rich game engine. There's a lot to learn about. The page explains how you can use the online manual, built-in code reference, and join online communities to learn about new features and techniques, making the most of this manual. What you are reading now is the user manual. It documents each of the engine's concepts and available features. When learning a new topic, you can start by browsing the corresponding section of this website. The left menu allows you to explore broad topics, while the search bar will help you find more specific pages. If a page exists for a given theme, it will often link to more related content. The manual has a companion class reference that explains each Godot's class available functions and properties when programming, while the manual covers general feature concepts and how to use the editor. The reference is all about using Godot scripting API application programming interface. You can access it both online and offline. We recommend browsing the reference offline from within the Godot editor. To do so, go to Help, Search Help, or press F1. To browse it online, head to the manual's class reference section. A class reference page tells you where the class exists in the inheritance hierarchy. You can click the top links to jump to parent classes and see the properties and methods a type inherits. So, physics body, concern collision object 2D, node 2D, canvas item, node object. Everything starts as an object and then becomes a node. A summary of the class's role and use cases, an explanation of the class's properties, methods, signals, enums, and constants, links to manual pages further detailing the class. Note, if the manual or class reference is missing or has insufficient information, please open an issue in the official Godot Docs GitHub repository to report it. You can control-click in the undefined underlying text, like the link of name of a class, property, method, signal, and constant to jump to it. Learning to think like a programmer, teaching programming foundations, and how to think like the game developers beyond the scope of Godot's documentation. If you're new to programming, we recommend two excellent resources, CS50, and if you prefer books, check out the free book, Automate the Boring Stuff with Python. Learning with the community. Godot has a growing community of users. If you're stuck on a problem or need help to better understand how to achieve something, you can ask other users to help. Best place to ask questions, find already answered ones, the official questions and answer site. Very nice. These responses show up in search engine results, get saved, allowing other users to benefit from discussions on the platform. Once you have asked a question there, you can share its link on the social platforms. before asking a question, be sure to look for existing answers that might solve your problem on the website or using your preferred search engine. Asking questions well and providing details will help others answer you faster and better. When asking questions, we recommend including the following information. Describe your goal. You want to explain what you are trying to achieve design-wise. If you're having trouble figuring out how to make a solution work, there may be a different, easier solution that accomplishes the same goal. If there's an error involved, share the exact error message. You can copy the exact error message in the editor's debugger button panel by clicking the copy error icon. Knowing what it says can help community members better identify how you triggered this error. If there is code involved, share a code sample. Other users won't be able to help you fix a problem without seeing your code. Share the code as text directly. To do so, you can copy and paste a short code snippet in a chat box or use a website like Pastebin to share long files. Share a screenshot of your scene doc along with your written code. Most of the code you write affects nodes in your scenes. As a result, you should think of those scenes as part of your source code. Also, please don't take a picture with your phone. The low quality and screen reflections can make it hard to understand the image. Alternatively, you can use a program. Sharing a video of your running game can also be helpful. If you're not using the stable version of Godot, please mention the version you're using. The answer can be different as available features and the interface evolve rapidly. Following these guidelines will maximize your chances. Okay, community tutorials. This manual aims to provide a comprehensive reference to Godot's features aside from 2D and 3D Getting Started series. It does not contain tutorials to implement specific game genres. If you're looking for a tutorial about creating the role-playing game, a platformer, or other, please see tutorials and resources, which list content made by Godot community. Godot's design philosophy. Now that you've gotten your feet wet, let's talk about Godot's design. Every game engine is different and fits different needs. Not only do they offer a range of features, but the design of each engine is unique. This leads to different workflows and different ways to form your game's structure. This all stems from their respective design philosophies. This page is here to help you understand how Godot works, starting with some of the core pillars. It is not a list of available features, nor is it an engine comparison. To know if any engine can be a good fit for your project, you need to try it out for yourself and understand the design limitations. Please watch Godot explained in 5 minutes if you're looking for an overview of the engine's features. Object-oriented design and composition. Godot embraces object-oriented design in its core with its flexible scene, system, and node hierarchy. It tries to stay away from strict programming patterns to offer an intuitive way to structure your game. For one, Godot lets you compose or aggregate scenes. It's like nested prefabs. You can create a blinking light scene and a broken lantern scene that uses the blinking light. Then create a city filled with broken lanterns. Change the blinking light's color, save, and all the broken lanterns in the city will update instantly. On top of that, you can inherit from any scene. A Godot scene could be a weapon, a character, an item, a door, a level, part of a level, anything you'd like. It works like a class in pure code, except you're free to design it by using the editor, using only the code, or mixing and matching the two. It's different from prefabs you find in several 3D engines, as you can then inherit from and extend those scenes. You may create a magician that extends your character, modify the character in the editor, and the magician will update as well. It helps you build your project so that the structure matches the game's design. Character, wait, move, jump. Wizard, cast, focus, wait, move, jump. Warrior, slash, rush, wait, move, jump. Also note that Godot offers many different types of objects called nodes, each with a specific purpose. Nodes are part of a tree and always inherit from their parents up to the nodes class. Although the engine does feature some nodes like collision shapes that a parent physics body will use, most nodes work independently from one another. In other words, Godot's nodes do not work like components in some other game engines. Sprite 2D is a node 2D. A canvas item is a node. It has all the properties and features of its 3 parent classes, like transformers or the ability to draw custom shapes and render with a custom shader. All-inclusive package. Godot tries to provide its own tools to answer most common needs. It has a dedicated scripting workspace, an animation editor, a tile map editor, a shader editor, a debugger, a profiler, the ability to hot reload locally and on remote devices. The goal is to offer a full package to create games and a continuous user experience. You can still work with external programs as long as there is an import plugin available in Godot for it, or you can create one like the tiled map importer. That is also partly why Godot offers its own programming language, GDScript, along with C#. GDScript is designed for the needs of game developers and game designers and is tightly integrated in the game engine and the editor. GDScript lets you write code using an indentation-based syntax. Ooh, I hate those. Yet it detects types and offers a static language's quality of auto-completion. It is also optimized for gameplay code with built-in types like vectors and colors. Note that with GD extension, you can write high-performance code using compiled languages like C, C++, Rust, D, Hex, or Swift without recompiling the engine. Note that the 3D workspace doesn't feature as many tools as the 2D workspace. You'll need external programs or add-ons to edit terrains, animate complex characters, and so on. Godot provides a complete API to extend the editor's functionality using game code. See the Godot editor is a Godot game below. A state machine editor plugin in Godot 2 by Kubser3K. It lets you manage states and transitions visually. Open source. Godot offers a fully open source code base under the MIT license. This means all the technologies that ship with it have to be free, as in freedom as well, for the most part. They're developed from the ground up by contributors. Anyone can plug in proprietary tools for the needs of their projects. They just won't ship with the engine. This may include Google AdMob or Fmod. Any of these can come as third-party plugins instead. On the other hand, an open code base means you can learn from and extend the engine to your heart's content. You can also debug games easily, as Godot will print errors with the stack trace, even if they come from the engine itself. This does not affect the work you do with Godot in any way. There's no strings attached to the engine or anything you make with it. Community driven. Godot is made by its community, for the community, and for all game creators out there. It's the needs of the users and open discussions that drives the core updates. New features from the core developers often focus on what will benefit the most users first. That said, although a handful of core developers work on it full-time, the project has over 600 contributors at the time of writing. Benevolent programmers, it's like 900 now. Benevolent programmers work on features they may need themselves, so you'll see improvements in all corners of the engine at the same time in every major release. The Godot editor is a Godot game. The Godot editor runs on the game engine. It uses the engine's own UI system. It can hot reload code and scenes when you test your projects, or run game code in the editor. This means you can use the same code and scenes for your games, or build plugins and extend the editor. This leads to a reliable and flexible UI system, as it powers the editor itself. With the tool annotation, you can run any game code in the editor. That's pretty sick. I'm excited about that. Oh, we got a viewer here. What's up, viewer? Thanks for dropping by. We're just reading docs right now. But we're checking out Godot, the open source game engine. The tool annotation at the top of any GDScript file, and it will run in the editor. This lets you import and export plugins, create plugins like custom level editors, or create scripts with the same nodes and API you use in your projects. The editor is fully written in C++ and is statically compiled into the binary. This means you can import it as a typical project that would have a project.godot file. Separate 2D and 3D engines. Godot offers dedicated 2D and 3D rendering engines. As a result, the base unit of 2D scenes is pixels. Even though the engines are separate, you can render 2D in 3D, 3D in 2D, and overlay 2D sprites and interfaces over your 3D world. Interesting. Engines are separate. All right, now we're into the step-by-step. We read the introduction. So you will get started with the editor and the engine. You will learn more about nodes and scenes, code your first classes with GDScript, use signals to make nodes communicate with one another, and more. The following lessons are here to prepare you for your first 2D game. Step-by-step tutorial where you will code a game from scratch. By the end of it, you will have the necessary foundation to explore more features in other sections. We also included links to pages that cover a given topic in depth where appropriate. All right. Nodes and scenes. In overview of Godot key concepts, we saw that a Godot game is a tree of scenes and that each scene is a tree of nodes. In this lesson, we explain a bit more about them. You will also create your first scene. Nodes. Nodes are the fundamental building blocks of your game. They're like the ingredients in a recipe. There are dozens of kinds that can display an image, play a sound, represent a camera, and much more. All nodes have the following characteristics. They've got a name, editable properties. They receive callbacks to update every frame. You can extend them with new properties and functions. You can add them to another node as a child. The last characteristic is important. Together, nodes form a tree, which is a powerful feature to organize projects. Since different nodes have different functions, combining them produces more complex behavior. As we saw before, you can build a playable character. The camera falls using character body 2D node, a sprite 2D and a camera 2D node, and a collision shape 2D node. When you organize nodes in a tree, like our character, we call this construct a scene. Once saved, the scenes work like new node types in the editor, where you can add them as a child of an existing node. In that case, the instance of the scene appears as a single node with its internals hidden. Scenes allow you to structure your game's code however you want. You can compose nodes to create custom and complex node types, like a game character that runs and jumps, a life bar, a chest with which you can interact, and more. The Godot editor essentially is a scene editor. It has plenty of tools for editing 2D and 3D scenes, as well as user interfaces. A Godot project can contain as many of these scenes as you need. The engine only requires one as your application's main scene. This is the scene Godot will first load when you or a player runs the game. On top of acting like nodes, scenes have the following characteristics. They always have one root node, like the character in our example. You can save them to your local drive and load them later. Okay. You can create as many instances of a scene as you'd like. You could have 5 or 10 characters in your game created from your character's scene. Creating your first scene. Let's create our first scene with a single node. To do so, you need to create a new project first, and after opening the project, you should see an empty editor. Let's do it. New. Let's make a new folder. Godot. 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 Okay, so I can create whatever I want. First, make it 2D. Yes, this is going to be 2D. Create and edit. Use version control. Cancel. Forward plus. I missed that. There's an option there. It's loading on my other monitor. Let me read this while it loads. In an empty scene, the scene dock on the left shows several options to add a root node quickly. 2D scene adds a 2D node, 3D scene adds a 3D node, or node 3D, and user interface adds a control node. These presets are here for convenience. They are not mandatory. Other node lets you select any node to be the root node. In an empty scene, other node is equivalent to pressing the Add Child Node button at the top left of the scene dock, which usually adds a new node as a child of the currently selected node. We're going to add a single label node to our scene. Its function is to draw text on the screen. Press the Add Child Node button or the other node to create a root node. The Create Node dialog opens, showing the long list of available nodes. Select the label node. We can type it's named, filter down, click the label node to select it, and click the create button at the bottom of the window. A lot happens when you add a scene's first node. The scene changes to 2D workspace because label is a 2D node type. The label appears selected in the top left corner of the viewport. The node appears in the scene dock on the left, and the node's properties appear in the inspector dock on the right. Cool. All right, so we are in 3D. I'm going to create a new other node. Was it on scene plus child's node? Oh, here we go. Other node. We're going to search for label. We're going to create a label. Now we're in 2D, just like they said. This is the inspector for it. I can type the text. Hello worlds. That work? Yes, I am making hello world node. Okay. Exactly. The next step is change the label's text property. Let's change it to hello world. All right, head to the inspector dock on the right of the viewport. Click inside the viewport below text property and type hello world. You will see the text draw on the viewport as you type. I did not see that. You can enter any property listed in the inspector as we do with the text. For complete reference to the inspector dock, see the inspector. You can move your label node in the viewport by selecting the move tool in the toolbar. With the label selected, click and drag anywhere in the viewport to move it to the center of the view delimited by the rectangle. Like I need to zoom in or something. I can't see it. I can't see it. Like, what is that? Undo. All right, this is my label. Now I can zoom. Okay, cool. And the blue rectangle must be the screen. And it's still not letting me drag it. There it goes. Okay. And where's the middle of the screen? Like, this is hard to use with a trackpad. Let me use my mouse. There we go. Much better. Cool. And let's just run it. Play. No main scene has ever been defined. Select one. You can change it later in project setting. Set current. Ooh, I don't know what to do. Let's see. Everything's ready to run. Yeah, it is kind of tiny. To run the scene, press the play scene button on the top right of the screen or press F6. Okay, so I hit the wrong button. Cancel. Run current scene versus run project. Okay. Still wants me to save it. A pop-up invites you to save the scene, which is required to run it. Click the save button in the file browser to save it as label TSN. TSCN. Something scene. Save scene as dialog, like other file dialogues in the editor, only allows you to save files inside the project. The red / path at the top of the window represents the project's root directory and stands for resource path. For more information about the file path in Godet, see file system. The application should open in a new window and display hello world. I missed it. Where'd the window go? Here. Hey, it worked. Cool. Close the window, setting the main scene. To run our test scene, we use the play scene button. Another button next to it allows you to set and run the project's main scene. You can press F5 to do so. The pop-up window appears and invites you to select the main scene. Click the select button and the file dialog that appears will double-click the label scene. The demo should run again. Moving forward, every time you run the project, Godet will use the scene as a starting point. The editor saves the main scene's path in a project Godet file in your project's directory. While you can edit this text file directly to change project settings, you can also use project settings. What the heck? Go away. In the next part, you will discuss another key concept in games in Godet, creating instance of a scene. What's up, Emiliano? Is that how you say it? Just working on reading the Godot docs. Creating instances. In the previous part, we saw that a scene is a collection of nodes organized in a tree structure with a single node as its root. You can split your project into any number of scenes. This feature helps you break down and organize your game's different components. You can create as many scenes as you'd like and save them as files, which stands for text scene. Okay, that's what the T stands for. The label text scene file from the previous lesson was an example. We call those files packed scenes, as they pack information about your scene's content. Here's an example of a ball. It's composed of a rigid body 2D node and its root named ball, which allows the ball to fall and bounce on walls, a sprite 2D node, and a collision shape 2D. Once you saved a scene, it works as a blueprint. You can reproduce it in other scenes as many times as you'd like. Replicating an object from a template like this is called instancing. Yeah, first time with Godot. I was doing other streams with Unreal Engine, but wasn't getting very far with the 2D game that we're trying to build. I've used Unity in the past, and Game Engine, and first engine I ever used, or Game Maker, and the first engine I ever used was Torque, Torque 2D. If you were ever around for that, that's what I used back in college. As we mentioned in the previous part, scenes behave like a node. The editor hides their content by default. When you instance the ball, you only see the ball node. Notice also how each duplicate has a unique name. Cool. Every instance of the ball scene starts with the same structure and properties as ball text scene. However, you can modify each independently, such as changing how they bounce, how heavy they are, or any property exposed in the opens. Okay, makes sense. In practice, let's use instancing in practice to see how it works in Godot. We invite you to download the ball's sample. Sure. Extract the archive on your computer. To import it, you need the project manager. The project manager is accessed by opening Godot, or if you already have Godot open, click project, quit to project lists, control the project. Okay. I never read the docs, but I'm trying to be better. And I'll just leave it in downloads for now. Quit Godot, quit to project list. Right. Import. I'm gonna go to downloads. Allow. Instance starter. Project Godot. Import and edit. Warning, this project was last edited in Godot 4. Opening will change it to Godot 4.2. Open anyways. Alright, browse button, navigate, project Godot, finally click the import button. The project contains 2 pack scenes, main TS scene, containing walls against which the ball collides, and ball TSN, the main scene. Okay. Ooh, it's so big on this other monitor. Let me fix that. There we go. Let's look at our 2 scenes, see if we can find them. So these are all the walls. So let's do the wall scene, the main one, the ball scene, and the main scene. Okay, I'm just gonna run it and see what happens. Okay, and I bet I click and it'll drop a ball, right? Oh, how did I know? And let's see how performant this is. If I can fill it with balls, what do you think is gonna happen? I can't hold it? No. Just keep clicking. I think I can break it. I can break such a small little game. Put one here. Yep. Put them down here. Yep. I heard the physics are weird in Godot. It's like popcorn. That's pretty cool. Let's add a ball as a child of the main node. In the scene dock, select the main node, then click the link icon at the top of the scene dock. This button allows you to add an instance of a scene as a child of the currently selected node. So click main, click link, double click the ball scene and instance it. The ball appears at the top left corner of the viewport. Click on it and drag it towards the center of the view. Play the game by pressing F5. Now we want to create more instances of the ball node with the ball selected. Press Ctrl D to call duplicate command. Click and drag the ball. So you can repeat the process until you have several in the scene. Play the game again. You should now see every ball fall independently from one another. This is the instance to do. Cool, I don't think I need to do that, but whatever. Link ball. Click to drag. I already forgot. Add node here. No. That they said oh, it would appear in the top left. They said okay. Do it again. They said Command D. Yep. And they are on top of each other. Cool. Just what you would think. Beautiful. Simple. To the point. All right. There are more instances. With the feature, you can change the properties of one ball without affecting the others using the inspector. Change the default properties of every ball by opening the ball text scene and making a change of the file. Ball node upon saving all instances of the ball in the project. Yeah, let's try that. I want to see what the text editor looks like. So if I double click this is the scene, but where's the... I guess there was no code behind this. Collision shape 2D, node 2D. Yeah, so it's not made up of anything but those and the sprites. So I can like change the color probably. Actually, do they let you affect the sprite here? You have a sprite editor. I thought they said they had a sprite editor. New viewport texture, new canvas, load, inspect. I'm jumping ahead, but I was just curious. There's the texture, inherit, material, new canvas material, new shader material. Interesting. You can mess with the collision. You can disable the collision. Then save it. Go back to our main scene. Run it. All the balls should go through. They did. Cool. Fancy, fancy. All right. Back to the ball scene. Re-enable. Save. Run again. Cool. Cool. Let's try this. Open ball scene. Select the ball node. Inspector physics. To expand it, set its bounce property to 0.5. Oh, that's what I was looking for. Something cool like that. Physics. What was it? Physics. Rigid body. There it is. Is it gravity? Expand. New physics. Edit. Friction. Rough bounce. 0.5 on the bounce. It's 0 right now. Oh, because it doesn't bounce at all. Is that right? That right. Now they're gonna bounce? Was that much of a bounce? Did you guys notice a bounce there? Didn't seem very bouncy. Play the game by pressing F5 and notice how all the balls now bounce a lot. Did not notice that. Let's do 0.5 again. Oh, maybe because I didn't hit enter. There we go. Haha. Bouncing balls. Now, adjust an individual instance, head back to the main scene, corresponding tab, select one of the instance ball nodes and an inspector set the gravity to 10. A gray revert button appears. All right, let's go do that. So ball 1, you're going to be special today. We're going to edit you, buddy. And your gravity is going to be, what they say, 1. Now, which one is being weird? This one? This one? It's got to be this one. Cool. Oh, she said 10. The docs are female. Okay, it's like cars. This guy? No. This guy? It's this one, right? Can't actually tell. So it's normally 4. What if I set it to 40? Ooh. Yeah, he's like killing all the other ones. Out of the balls. Oh, one more. Get him. Yeah. That's pretty cool. The icon indicates you are overriding a value from the source pack scene. Even if you modify the property of the original scene, the value override will be preserved in the instance. Clicking the revert icon will restore the property of the value in the saved scene. Rerun the game and notice how the ball now falls much faster than the others. Note, you may notice you are unable to change the values of the physics material of the ball. This is because physics material is a resource and needs to be made unique before you can edit it in a scene that is linking it to its original scene. To make a resource unique for one instance, right-click on the inspector and click Make Unique in the contextual menu. Resources are another essential building block of Godot games. We will cover in later lessons. Okay, that I didn't quite track, actually. That seems a little more complex. So it's saying I can't update this because it's a resource. Okay, I get that it's a resource. I don't understand why. Where's the Make Unique option? Okay, I made it unique. What did that do? Messed with the friction. Okay, what if I don't want it to be unique anymore? New physics material. Not sure. Hopefully get back to it. All right, scene instances as a design language. Instances and scenes at Godot offer an excellent design challenge, setting the engine apart from others out there. We designed Godot around this concept from the ground up. We recommend dismissing architectural code patterns when making games with Godot, such as model view controller or entity relationship diagrams. Instead, you can start by imagining the elements players will see in your game and structure your code around them. For example, you could break down a shooter game like this. Obstacle HUD, market, weapon, player ship, enemy, stage, missile, enemy, weapon, instance by code. You can come up with a diagram like this for almost any type of game. Each rectangle represents an entity that's visible in the game from the player's perspective. The arrows tell you which scene owns which. Once you have a diagram, we recommend creating a scene for each element listed in it. To develop your game, you'll use instancing either by code or directly in the editor to build your tree of scenes. Programmers tend to spend a lot of time designing abstract architectures and trying to fit components into it. Designing based on scenes makes development faster and more straightforward, allowing you to focus on the game logic itself. Because most game components map directly to a scene, using a design based on scene instantiation means you need a little other architectural code. Here's an example of a scene diagram for an open world game with tons of assets and nested elements. So everything's on the terrain. So a house has a door and a room has a chair and a table has a vase. Church has a seat a citadel has a house and a church. A bridge has guards. Player has a HUD. Imagine we started by creating the room. We could make a couple of different room scenes with unique arrangements of furniture in them. Later, we can make a house scene that uses multiple room instances for the interior. We would create a citadel out of many instanced houses in a large terrain on which we would place the citadel. Each of these would be a scene instancing one or more sub-scenes. Later, we could create scenes representing guards and add them to the citadel. They would be indirectly added to the overall game world. With Godot, it's easy to iterate on your games like this, as all you need to do is create and instantiate more scenes. We design the editor to be accessible to programmers, designers, and artists alike. A typical team development process can involve 2D or 3D artists, level designers, game designers, animators, all working with the Godot editor. Instancing the process of producing an object from a blueprint has many handy uses. With scenes, it gives you the ability to divide your game into reusable components, a tool to structure and encapsulate complex systems, a language to think about your game's project structure in a natural way. I'm fine with all that. I don't think you need crazy design patterns here. I want to see how they get to the scripting language. Oh, that's the next bit. This lesson will give you an overview of the available scripting languages in Godot. You'll learn the pros and cons of each option. In the next part, you will write your first script in GDScript. Scripts attach to a node and extend its behavior. This means that scripts inherit all functions and properties of the node they attach to. For example, take a game where a camera 2D node follows a ship. The camera 2D node follows its parent by default. Imagine you want the camera to shake when the player takes damage. As this feature is not built into Godot, you would attach a script to the camera 2D node and code the shake. Available scripting languages. Godot offers 4 gameplay programming languages: GDScript, C#, and via the GD extension technology, C and C++. There are many community-supported languages, but these are the official ones. You can use multiple languages in a single project. For instance, in a team, you could code gameplay logic in GDScript, as it's fast to write, and use C# or C++ to implement complex algorithms and maximize their performance. Or you can write everything in GDScript or C#. It's your call. You provide the flexibility to answer the needs of different game projects and developers. Which language should I use? If you're a beginner, we recommend to start with GDScript. We made this language specifically for Godot and the needs of game developers. It has a lightweight and straightforward syntax and provides the tightest integration with Godot. Extends area 2D, signal hit, export var speed 200 or 400, var screen size. Oh, it's actually like Python. Func_process, var direction calculate, move direction, var velocity direction speed, if velocity dot length greater than 0, animate its sprite dot play. How do you know this has an animated sprite on it? Where's that reference coming from? Position plus equals velocity times delta, position x equals clamp position. For C#, you'll need an external code editor like VS Code or Visual Studio. With C# support is now mature, you will find fewer learning resources for it compared to GDScript. That's why we recommend C# mainly to users who already have experience with the language. Let's look at each language's features as well as its pros and cons. GDScript. GDScript is an object-oriented and imperative programming language built for Godot. It's made by and for game developers to save you time coding games. Its features include a simple syntax that leads to short files, blazing fast compilation and loading times, tight editor integration with code completion for nodes, signals, and more information from the scenes it's attached to. Built-in vector and transform types, making it efficient for heavy use of linear algebra and a must for games. Supports multiple threads as efficiently as statically typed languages. No garbage collection, as this feature eventually gets in the way when creating games. The engine counts references and manages the memory for you, in most cases by default, but you can also control memory if you need to. Interesting. Gradual typing. Variables have dynamic types by default, but you also can use type hints for strong type checks. Gradual typing. Can't say I've heard of gradual typing. Correctness of the type is checked at compile time. And some expressions may be left untyped, and eventually type errors are reported at runtime. Gradual typing allows software developers to choose either typing pattern as appropriate from within a single language. Oh, okay, so you get your choice. Good. One strong typing. GDScript looks like Python. Yeah, as you structure code blocks using indentations, but it doesn't work the same way in practice. It's inspired by multiple languages, including Squirrel, Lua, and Python. Never heard of Squirrel. Why don't we use Python or Lua directly? Years ago, Godot used Python, then Lua. Both languages integration took a lot of work and had severe limitations. For example, threading support was a big challenge with Python. It's probably better now. Developing a dedicated language doesn't take us more work, and we can tailor it to game developers' needs. We're now working on performance optimization features that would have been difficult to offer with third-party languages. .NET C#. As Microsoft C# is a favorite amongst game developers, we officially supported C# as a mature and flexible language with tons of libraries written for it. We were able to add support for it thanks to generous donation from Microsoft. Oh, sick. C# offers a good trade-off between performance and ease of use, allowing you, although you should be aware of its garbage collector. You must use the .NET edition of the Godot editor to script in C#. You can download it on the Godot website's download page. Since Godot uses .NET 6, in theory, you can use any third-party .NET library or framework in Godot, as well as any common language infrastructure and compliant programming language such as F#BOO or Clojure CLR. However, C# is the only official supported .NET option. GDScript code itself doesn't execute as fast as compiled C# or C++. However, most script code calls functions written with fast algorithms in C++ code inside the engine. In many cases, writing gameplay logic in GDScript, C# or C++ won't have significant impact on performance. Attention, projects written in C# using Godot 4 currently cannot be exported to the web platform. To use C# on that platform, consider Godot 3 instead. Android and iOS platform support is available as of Godot 4.2, but is experimental and some limitations apply. C++ via GD extension. GD extension allows you to write game code in C++ without needing to recompile Godot. Why would you bother? You can use any version of the language or mix compiler brands and versions of the generated shared libraries, thanks to our use of the internal C API bridge. GD extension is the best choice for performance. You don't need to use it throughout an entire game, as you can write other parts in GDScript. Okay, so that's why you do it, for the performance, of course. When working with GD extension, the available type functions and properties closely resemble Godot's actual C++ API. Scripts are files containing code that you attach to a node to extend its functionality. Godot supports 4 official scripting languages, offering you flexibility between performance and ease of use. You can mix language, for instance, to implement demanding algorithms with C or C++ and write most of the game logic with GDScript or C#. All right, creating your first script. In this lesson, you will code your first script to make the Godot icon turn in circles using GDScript. As we mentioned in the introduction, we assume you have programming foundations. The equivalent C# code has been included in another tab for convenience. There are tabs. See also, to learn more about GDScript, its keywords and syntax, head to GDScript reference. To learn more about C#, head to the C# basics page. Project setup. Create a new project to start with a clean slate. Your project should contain one picture, the Godot icon, which we often used for prototyping in the community. We need to create a Sprite 2D node to display in the game. In the scene dock, click the Other Node button, type Sprite 2D in the search bar to filter nodes, and double-click on Sprite 2D to create the node. Your Scene tab should now only have a Sprite 2D node. Sprite 2D node needs a texture to display. In the inspector on the right, you can see that the texture property says empty. To display the Godot icon, click and drag the file icon SVG from the file system dock onto the texture slot. You can create Sprite 2D nodes automatically by dragging the drop-in images in the viewport, then click and drag the icon into the viewport center in the game view. Creating a new script, you can create and attach a new script to our node. First, click on Sprite 2D in the scene dock and attach script. Attached node script window appears. It allows you to select the script's language and file path among other options. Change the template field from node default to object empty to start with a clean file. Leave the other options set to their default values and click the create button to create the script. C# script names need to match their class name. In this case, you should name the file mysprite2d.cs. The script workspace should appear with your new Sprite 2D GD file open in the following line of code. Extend Sprite 2D. There's the tab. Using Godot. Public partial class. mysprite2d. Sprite 2D. Every GD script file is implicitly a class. The extends keyword defines the class the script inherits and extends. In this case, it's Sprite 2D, meaning our script will get access to all the properties and functions of the Sprite 2D node, including classes it extends like node 2D, canvas item, and node. In GD script, if you omit the line with the extends keyword, your class will implicitly extend ref counted, which Godot uses to manage application memory. Inherited properties include the ones you can see in the inspector dock, like our node's texture. By default, the inspector displays a node's properties in title case with capitalized words separated by a space. In GDScript code, these properties are in snake case, so Python, which is lowercase with words separated by an underscore. You can hover over any property's name in the inspector to see the description of it and its identifier code. Hello world. Our script currently doesn't do anything. Let's make it print the text hello world to the output bottom panel to get started. Add the following code to your script. GD print hello world or print hello world. Let's break it down. The func keyword defines a new function named init. This is a special name for our class's constructor. The engine calls init on every object or node upon creating it in memory if you define this function. GDScript is an indent-based language. The tab at the start of the line that says print is necessary for the code to work. If you omit it or don't indent a line correctly, the editor will highlight it in red and display the following error message: indented block expected. Save the scene as Sprite 2D. If you haven't already, then press F6 to run it. Look at the output. Bottom panel expands it. It should say hello world. Cool. Project. Quit to project list. Don't save. Open up my first project again. Wait for it to load. Shrink it. Move it to my new monitor. This had a label in it. I'm going to delete that. We're going to do other Sprite 2D, right? Yep. Cool. We're going to add a script. Not label. Guy Sprite GD. Object empty. Great. Func. Type func score init tab. Yep. Print. Cool. It's He's mad. Why are you mad? Parse error identifier hello not declared in the current scope. Oops. Let me see if they have shortcuts here. They do. Good. Save. Okay. I'm missing the sprites. Texture. Did they say where I could get the texture? Icon. Beautiful. Hello world. Okay. I am going through the Hello World 2D tutorial for Godot, an open source game engine. I was building a game in Unreal Engine for a friend of mine. Didn't get very far because there's a lot of it's a big learning curve in Unreal Engine. Godot, on the other hand, seems very straightforward so far. All right, so I ran that, and then it says delete the init function, so you're only left with the extends. Turning around, it's time to make your node move and rotate. To do this. To do so, we're going to add two member variables to our script, the movement speed in pixels per second and the angular speed in radians per second. Add the following after the extends line. Var speed, angular speed. Angular speed is pi. Nice. Speed 400. Was it var? I can't remember. Angular speed equals 400. And then the radians thing, what was that? Not angular speed. Oh, the first one's speed. The second one is angular speed. Okay. Speed. Angular speed. Pi. Cool. It was var, right? Yeah, var. In C#, it would have been private int underscore speed, angular speed. All right. Member variables sit near the top of the script after any extends lines, but before functions. Every node instance with this script attached to it will have its own copy of the speed and angular speed properties. Angles in Godot work in radians by default, but you have built-in functions and properties available if you prefer to calculate angles in degrees instead. To move our icon, we need to update its position and rotation every frame in the game loop. We can use the process virtual function of the node class. If you define it in any class that extends the node class like Sprite2D, Godot will call the function every frame and pass it an argument named delta, the time elapsed since the last frame. Games work by rendering many images per second, each called a frame, and they do so in a loop. We measure the rate at which a game produces images in frames per second. Most games aim for 60 FPS, although you might find figures like 30 FPS on slower mobile devices or 90 to 240 for virtual reality games. The engine and game developers do their best to update the game world and render images at a consistent time interval, but there are always small variations in frame render times. That's why the engine provides us with the delta time value, making our motion independent of our frame rate. At the bottom of the script, define the function func process delta, rotation plus equals angular speed times data. So rotation will equal angular speed times delta. Process func process func process delta rotation equals angular speed times oh my gosh, just keep delta. Okay, does that actually work? Guess I don't have it set, so it's not going to do anything. Okay. The func keyword defines a new function. After it, we have to write the function's name and arguments. Oh, you know what? I also forgot got this, which is important. Where did I map this key on my freaking keyboard? The equals, right? Okay. Notice how process like init starts with the leading underscore. By convention, Godot's virtual functions, that is to say, built-in functions, you can override to communicate with the engine, start with an underscore. The line inside the function, rotation plus equals angular speed times delta, increments our sprite's rotation every frame. Here, rotation is a property inherited from the class node2d with sprite2d extents. It controls the rotation over a node and works with radians. In the code editor, you can control-click on any built-in property or function like position, rotation, or process to open the corresponding documentation in the tab. Run the scene to see the Godot icon turn in place. All right, cool, it worked. Let's see if we can see the property. Yeah, it's float, rotation 0.0 by default, set rotation is the setter, get rotation is the getter. So that means, in theory, I should be able to use a setter instead. Set sets rotation or something like that, right? Problem is I still need to add it to the start, or I still need to add the starting number. Okay, didn't work, but I was just curious. It said set rotation was a setter. I wonder if I can go back. Nope. In C#, notice how the delta argument taken by process is a double. We therefore need to convert it to float when you apply its rotation. Is that right? Angular speed times float delta. Moving forward, let's now make the node move and the following two lines, add the following two lines in the process function, ensuring the new lines are indented the same way as the rotation plus equals angular squared times delta line before them. All right, if our velocity is vector2 up, rotated by the rotation times the speed, that gets us the velocity. And then we change the position based on the velocity and the time passed since the previous frame. As we already saw, the var keyword defines a new variable. If you put it at the top of the script, it defines a property of the class. Inside a function, it defines a local variable. It only exists within the function scope. We define a local variable named velocity, a 2D vector representing both a direction and a speed. To make the node move forward, we start with a vector2 class's constant up. A vector pointing up and rotate it by calling the vector2d method rotated. This expression, vector2d up rotated, rotation is a vector pointing forward relative to our icon. Multiplied by our speed property, it gives us a velocity we can use to move the node forward. We add velocity times delta, so the node's position to move it. The position itself is of type vector2, a built-in type in Godot is representing a 2D vector. Run the scene to see Godot head run in circles. So velocity is a vector2 up, position or rotated with past in rotation times the speed. Ooh, be hard to remember. So var velocity equals vector up, vector2 dot up. Dot rotated? Yeah, rotated. The rotation. And then times something over. So if that just gives us the rotation, we don't times it by the delta yet. I forgot the next piece. Okay, and now we do, we use the velocity to change the position. Right? Position equals And it was velocity times delta. Oops. Hey, excuse me. There you go. All right, let's see. I'm missing something here. I just can't remember what it was. The velocity can't be the rotated up. Maybe it can. Oops, I messed that up. Put that in there. Cancel. Okay, that's the script. Oh, and then I have to add the script to the scene because I messed that up because I deleted it. Oops. Attach script. I want to attach a new script. I want this script. I'm going to save over it. Can I drag it onto it? That work? Did I make a sprite scene? I could have sworn I made a sprite scene. This needs the vector image again. Save. Okay, it's not moving because I forgot something. All right, let's see what I forgot. Speed. And the speed came from this was passed in. Okay, we never used the speed. Well, now we know why. Was it plus or times? Let's just say it was plus. Crashed. Spin times. Didn't work. Plus equals. I keep forgetting to do that. Yo. And then let's update the scene here. How do I open the scene? Close the editor. Go back to 2D. That's how. I can move this guy. Hey, can you just let me move you? You want to? I move around scene. It's gotta be a way to drag, right? There you go. Mouse wheel click. Click you. Click you. Drag. Cool. This looks wider, but we add velocity times delta to the node's position to move it. Velocity times delta. So I did, okay. Moving a node like that does not take into account colliding with walls or the floor. In your first 2D game, you will learn another approach to moving objects while detecting collisions. Our node currently moves by itself. In the next part, listening to player input, you'll use player input to control it. Complete script. Listening to player input. All right, listening to player input. Building upon the previous lesson, creating your first script, let's look at another important feature of any game, giving control to the player. To add this, we need to modify our Sprite 2D GD code. You have two main tools to process the player's input in Godot. The built-in input callbacks, mainly unhandled input, like process, it's a built-in virtual function that Godot calls every time the player presses a key. It's the tool you want to use to react to events that don't happen every frame, like pressing space to jump. To learn more about input callbacks, see using input event. The input singleton A singleton is a globally accessible object. Godot provides access to several inscripts. It's the right tool to check for input every frame. We're going to use input singleton here as we need to know if the player wants to turn or move every frame. For turning, we should use a new variable direction, and our process function replace the rotation plus angular speed times delta line with the code below. Our direction equals 0 if input is action pressed UI left. UI. Would it be called user interface? Direction equals -1. If it's right, direction is 1. And then you have to do times direction. Input is action pressed. Input is action pressed. Is action pressed. Interesting. Not this one. There's no velocity anymore, right? There's still velocity. No velocity. Instead, replace velocity. This rotation. What about velocity? Do I keep velocity then? Let's keep velocity for a second. Get tired. Okay. Our direction equals input dot something action press UI event UI left, something like that. Action press UI left. Direction equals -1. I see what I did. This should be 0. This should be an if. This should be tabbed. All right, if input action pressed, if action is action pressed, is action pressed UI left. If input is action pressed UI left colon, because that's how you do ifs. Okay. And they're not doing an else here. Okay, I'll probably try to keep it simple. Input dot is action pressed. Right. UI. Right. Direction equals 1. Position, no, rotation becomes plus equals angular speed. This guy. Oops, why would you paste that? Rotation equals plus equals angular speed times delta times direction. Our direction local variable is a multiplier representing the direction in which the player wants to turn. A value of 0 means the player isn't pressing the left or the right arrow key. A value of 1 means the player wants to turn right, and -1 means they want to turn left. To produce these values, we introduce conditions and the use of input. A condition starts with the if keyword in GDScript and ends with a colon. The condition is the expression between the keyword and the end of the line. To check if a key was pressed this frame, we call input is action pressed. The method takes a text string representing an input action and returns true if the action is pressed, false otherwise. The two actions we use above, UI left and UI right, are predefined in every Godot project. They respectively trigger when the player presses the left and right arrows on the keyboard or left or right on the game's D-pad. You can see and edit input actions in your project by going to Project Settings, and clicking on the Input Map tab. Finally, we use the direction as a multiplier when we update the node's rotation. Rotation plus equals angular speed times direction times delta. If you run the scene with this code, the icon should rotate when you press left and right, moving when pressing up. The only move when pressing a key to only move when pressing a key, we need to modify the code that calculates the velocity. Replace the line starting with var velocity with the following below. I want to see what this does as is. Okay. Let's do it faster, but with some arrow keys. Cool. And left. Right, left, right. Pretty cool, pretty cool, pretty cool, pretty cool. All right, and it's going to eventually go off the map. All right, var velocity starts out as vector to 0 now. And then if the input press is up, the velocity will be vector up times rotated. Rotation speed, the whole thing. So let's change that. Start you off with 0, which was a vector 2 dot 0. 0. Yeah, it was 0. Okay. Okay. And then now we say if input dot is action pressed UI underscore up. Okay. Gotta do that. Colon. Then velocity equals, is it equals or plus equals? Equals, plus equals, equals, plus equals. Let's try plus equals, but I have a feeling this one actually is equals. This one is equals. All right, so it doesn't move by default. Hit right, hit left, it turns. Hit up, and it moves. Very cool. We got a game now, guys. This is officially a game. Okay, maybe not quite yet. All right. Here's the complete script. You run the scene, you should now be able to rotate left and right. Summary. In summary, every script in Godot represents a class and extends one of the engine's built-in classes. The node types your classes inherit from give you access to properties such as rotation, position, and our sprite's case. You also inherit many functions, which we didn't get to use in this example. In GDScript, the variables you put at the top of the file are your class's properties, also called member variables. Besides variables, you can define functions, which, for the most part, will be your class's methods. Godot provides several virtual functions you can define to connect your class with the engine. These include process to apply changes to the node every frame, and unhandled input to receive input events like key and button presses from the users. For jumping, not for actually moving. For moving, use input. There are quite a few more. The input singleton allows you to react to the player's input anywhere in your code. In particular, you'll get to use it in the process loop. In the next lesson, using signals, we'll build upon the relationship between scripts and nodes by having our nodes trigger code in scripts. All right, well, let's finish up this section here. We'll probably do the Your First 2D Game on the next stream. Using signals. In this lesson, we will look at signals. They are messages that nodes emit when something specific happens to them, like a button being pressed. Other nodes can connect to that signal and call a function when the event occurs. Signals are a delegation mechanism built into Godot that allows one game object to react to a change in another without them referencing one another. Very cool. Observer pattern. Using signals limits coupling and keeps your code flexible. For example, you might have a life bar on the screen that represents the player's health. When the player takes damages or uses a healing potion, you want the bar to reflect the change. To do so, in Godot, you would use signals. As mentioned in the introduction, signals are Godot's version of the observer pattern. You can learn more about it here. GameProgrammingPatterns.com. We will now use a signal to make our Godot icon from the previous lessons. Listening to player input, move and stop by pressing a button. To add a button to our game, we will create a new main scene, which will include both a button and the Sprite 2D text scene we created in the Creating Your First Script lesson. Create a new scene by going to the menu Scene, New Scene. In the Scene dock, click the 2D Scene button. This will add a Node 2D as our root. In the File System dock, click and drag the Sprite 2D scene file you saved previously onto the Node 2D to instantiate it. What's up? What's up, viewer? Just wrapping up doing a tutorial for Godot. We want to add another node as a sibling of the Sprite 2D. To do so, right-click on the Node 2D, select Add Child Node. I missed this part. In the File System dock, click and drag the 2D seed file you saved previously onto the Node 2D. Instantiate it. Then add another child node, and that's where you put the button. The node is small by default. Click and drag on the bottom right hand button viewport, resize it. If you don't see the handles, ensure you select the tool icon. Click and drag on the button itself to move it closer to the sprite. You can also write a label on the button by editing the text in the inspector. Enter toggle motion. Your scene tree and viewport should look like this. Save your newly created scene as Node 2D. If you haven't already, you can then run it with F6. At the moment, the button will be visible, but nothing will happen if you press it. Cool. So it said new scene, not new node. New scene, new node, new scene, new node, new scene, file, new scene. There we go. 2D scene. They wanted me to drag my sprite scene onto the 2D scene, I believe. And if we actually open this, nope, can't open it. Right click, add child node. This is where we add button. Button. Okay. Now I want to see 2D. And where's the button? So I'm in the wrong scene. All right. It's really small. Okay, it's over here. It did say that it would be small. I have to go to this icon. Get really big. It's my mouse here. Oh, it's not that big, but okay. There we go. Give some text. Toggle something, right? Toggle movement, position. I think it was like position or something like that. All right, let's save this as Node 2D. And then run it. There it is. It does nothing. I can still move though. Cool. Connecting a signal in the editor. Here we want to connect the button's pressed signal to our Sprite 2D. And we want to call a new function that will toggle its motion on and off. We need to have a script attached to the Sprite node, Sprite 2D node, which we do from the previous lesson. You can connect signals in the node dock, select the button node, and on the right side of the editor, click on the tab named Node next to the inspector. Button node. Okay, here's all the signals. There's probably a pressed one, button down, pressed. The dock displays a list of signals available on the selected node. Pressed. Double-click the press signal to open the node connection window. There you can connect the signal to the Sprite node. The node needs a receiver method, a function that Godot will call when the button emits the signal. The editor generates one for you. By convention, we name these callback methods. On node name signal name. Here it'll be on button pressed. Just connect that guy on button pressed. and it created a new function for me. The advanced view lets you connect to any node and any built-in function, add arguments to the callback, and set options. You can toggle the mode in the Windows bottom right by clicking the advanced button. Click the connect button to complete the signal connection and jump to the script workspace. You should see the new method with the connection icon in the left margin. If you click the icon, a window pops up and displays information about the connection. This feature is only available when connecting nodes in the editor. Let's replace the line with the pass keyword with code that'll toggle the node's motion. Our sprite 2D moves things to code in the process function. Godet provides a method to toggle processing on and off. Node.setProcess. Another method of the node class isProcessing returns true if idle processing is active. We can use the not keyword to invert the value. So function on button pressed, set process, not is processing. The function will toggle processing and in turn the icon's motion on and off upon pressing the button. Before trying the game, you need to simplify our process. We need to simplify. Function to move the node automatically and not wait for user input. Replace it with the following code, which we saw 2 lessons ago. Process delta of rotation plus angular speed times delta. All right, so this is putting it back to move automatically, which I don't like. Okay. Go ahead and do that. But we're going to do this in the meantime. Oh, took me to the wrong thing. And they don't let me automatically comment it out. The shortcut doesn't work. Sad. Indent toggle comment. There we go. Func _process delta. I put a T in my func, and then damn it. Yeah. And then this guy becomes set process input. Set process not process mode. I don't know. Oh, not is processing. Not is processing. Is that it? Something like that. The process not is process. Yeah. Run the scene now. Click the button to see the sprite start and stop. Connecting the signal via code is the next thing we're going to do. Save that. So, running the wrong scene because the default is set to the old scene. Nope. Gotta go back. Go back to the scene. Now I can do it. Cool. Stop. Start. Stop. Start. Stop. Cool. Works. And then you can connect signals via code instead of using the editor. This is necessary when you create nodes or instantiate scenes inside of a script. Let's use a different node here. Godet has a timer node that's useful to implement skill cooldown times, weapon reloading, and more. Head back to the 2D workspace. You can either click the 2D text at the top of the window or press blah, 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 blah. In the scene dock, right-click on the Sprite 2D node and add a new child node. Search for timer and add the corresponding node. Your scene should now look like this. With the timer node selected, go to the inspector and enable the auto start property. Click the script icon next to Sprite 2D to jump back to the scripting workspace. You need to do 2 operations to connect the node via code. Get a reference to the timer from the Sprite 2D. Call the connect method on the timer's timeout signal. To connect to a signal via code, you need to call the connect method of the signal you want to listen to. In this case, we want to listen to the timer's timeout signal. We want to connect the signal when the scene is instantiated, and we can do that using the node.ready built-in function. which is called automatically by the engine when a node is fully instantiated. To get a reference to a node relative to the current one, we use the method node.getNode. We can store the reference in a variable. So func ready var timer equals getNode timer. The function getNode looks at the sprite 2D's children and gets nodes by their name. For example, if you rename the timer node blinking timer in the editor, you would have to change the call to getNode blinking timer. You can now connect the timer to the sprite 2D in the ready function. Ready var timer getNode timer timer.timeout.connect on timer timeout. The line reads like so. We connect the timer's timeout signal to the node to which the script is attached. When the timer emits timeout, we want to call the function onTimerTimeout that we need to define. Let's add it at the bottom of our script and use it to toggle our sprite's visibility. By convention, we name these callback methods in GDScript as onNodeName signal name. So onTimerTimeout is the signal name. And in C# as onNodeName signal name. Here it'll be onTimerTimeout for GDScript and onTimerTimeout in C#. OnTimerTimeout, visible equals not visible. The visible property is a boolean that controls the visibility of our node. The line visible equals not visible toggles the value if visible is true and becomes false if vice versa. If you run the scene now, you will see the sprite blink on and off at 1 second intervals. Oh, so the timer just keeps going. Okay. Let's see how much of that we can do from memory. Okay, so there was the func like on ready or something. Func ready. And we set a var timer is equal to you have to get node. It's like node dot underscore I already forgot. You get the node, you get node timer. Get node timer. Maybe it's without this. And then you say timer dot timer dot timer. Doesn't seem right. Timeout, call timeout. No, it was timer.timeout.connect. Timer.timeout, which is the signal, .connect, and then you want to connect to the function name, which was on timer timeout. And you want a function named on timer timeout and inside of that you want to choose visible equals not visible. Okay, it doesn't know what a timer is, doesn't know what visible is. Identifier node not declared in the current. Did I miss something there? Get node. There's no node get node, it's just get node. Get node timer, visible equals not visible. Okay, that one just looks correct. On timer timeout is the name of the function, but that's what I called it. Okay. Just be mad about nothing. Equals not visible. Yep, that's what I called it. Do you not need the parentheses? No, you need the parentheses. Okay. All right. Maybe you need a new line. Identifier visible, not declared. It's just a lie. Okay, so on the button, we want to add a new child called timer. Want to go to the timer inspector and choose auto start. Okay, is visible capitalized or something? Just doesn't know about visible, huh? Wonder if that doesn't exist anymore. It's right here. Well, that was weird. Did I typo it? Ah, I did typo it. Visbile. Okay. Sybil. What the heck? Visible. Jeez, I need sleep. All right. Restart the scene. Functions ready. Timeout on base null instance. Invalid get index timeout on base null instance. Timer get node timer. Right? It's here. Oh, I put it on the button. I would explain it. Am I supposed to put it on the sprite or the sprite scripts? Because the sprite has a script on it, right? Where's the sprite script? Where's the sprite script? Am I crazy? Oh, there it is. Script. Okay. Yep, there it goes. And I can stop it. And it blinks on and off. Coolio. The complete script, custom signals. This section is a reference on how to define and use your own signals. It does not build upon the project created in previous lessons. You can define custom signals in a script. Say, for example, that you want to show a game over screen when the player's health reaches 0. To do so, you would define a signal named died or health depleted when their health reaches 0. Extends signal health depleted var health equals 10. As signals represent events that just occurred, we generally use an action verb in the past tense in their names. Your signals work the same way as built-in ones. They appear in the node tab and you can connect to them like any other. To emit a signal in your scripts, call emit on the signal. Take damage, amount, health minus equals amount. If health is less than equals 0, health depleted dot emit. A signal can optionally declare one or more arguments, specifically the argument names between parentheses. Health changed, old, new, var 10. The signal arguments show up in the editor's node doc, and Godet can use them to generate callback functions for you. However, you can still emit any number of arguments when you emit signals, so it's up to you to emit the correct values. To emit values along with the signal, add them as the extra argument to the emit function. Health change.emit old health. Any node in Godet emits signals when something specific happens to them, like a button being pressed. Other nodes can connect to individual signals and react to selected events. Signals have many uses. With them, you can react to a node entering or exiting the game world, to a collision, to a character entering or leaving an area, to an element of the interface being changing size, and much more. For example, an area 2D representing a coin emits a body entered signal whenever the player's physics body enters its collision shape, allowing you to know when the player collected it. In the next section, your first 2D game, you'll create a complete 2D game and put everything you learned so far into practice. Awesome. Well, let's pick it up hopefully tomorrow. Let's see how I feel after work, but I'm enjoying this so far. It's very intuitive. Nothing has surprised me yet, and everything's just worked. So very happy with it so far. I can see us, increasing our velocity on the game we want to build pretty rapidly. All right, well, I do appreciate you guys watching, and see you next time. Here, droids.